In the ever-evolving world of software development, there exists a path towards building more flexible, scalable, and maintainable systems. This path is not just a trend, but a significant shift in how we approach software design and architecture. It represents a move away from monolithic structures that can be cumbersome and difficult to manage towards a more modular and dynamic way of thinking. This path leads us to the realm of microservices, a way of designing software as a collection of small, independent services that work together in harmony. Each service is designed to handle a specific task, and they communicate with each other through well-defined interfaces. This modular approach allows for greater flexibility and scalability, as each service can be developed, deployed, and scaled independently. Imagine a bustling city, with its diverse neighborhoods, each serving a specific purpose, yet interconnected as a whole. Each neighborhood has its own unique character and function, but they all contribute to the overall functioning of the city. This is akin to how microservices operate within a software system. Microservices embrace a similar philosophy, breaking down complex applications into smaller, manageable units. By decomposing a large application into smaller services, we can focus on individual components without being overwhelmed by the entire system. This makes it easier to develop, test, and maintain each part of the application. Just as a city thrives on the efficient functioning of its individual components, so too do microservices-based applications rely on the seamless interaction of their constituent services. Each service must perform its role effectively and communicate with other services to ensure the overall system operates smoothly. Each microservice focuses on a specific business capability, operating independently while communicating with others through well-defined interfaces. This independence allows teams to work on different services simultaneously, speeding up development and deployment processes. It also means that if one service fails, it doesn't bring down the entire system, enhancing the overall resilience of the application. This approach offers numerous benefits, empowering development teams to build and deploy software with greater agility and resilience. Teams can adopt different technologies and frameworks for different services, choosing the best tool for each job. This flexibility leads to more innovative solutions and a more robust software ecosystem. Let us delve deeper into the world of microservices and explore how they are transforming the landscape of modern software development. From improving scalability and flexibility to enhancing resilience and innovation, microservices are paving the way for the future of software architecture. Join us as we uncover the principles, practices, and benefits of embracing the microservices path. Microservices, at their core, represent an architectural style for building software applications. Unlike traditional monolithic architectures, where an entire application is built as a single, tightly coupled unit, microservices break down the application into a collection of smaller, loosely coupled services. Think of a monolithic application as a large, intricate machine where all the parts are interconnected and interdependent. Now, imagine dismantling this machine into smaller, more manageable components, each responsible for a specific function. This is the essence of microservices. Each microservice operates independently, encapsulating a specific business capability. For instance, in an e-commerce application, there might be separate microservices for user authentication, product catalog management, order processing, and payment gateway integration. This modular approach brings forth a plethora of advantages, ranging from enhanced scalability and fault tolerance to improved agility and faster development cycles. By decomposing complex applications into smaller, more manageable units, microservices pave the way for building more robust and adaptable software systems. The shift from monolithic architectures to microservices brings forth a wave of benefits, transforming the way we design, develop, and deploy software applications. This transition is not just a technical shift, but a paradigm change that impacts every aspect of software engineering. This architectural style liberates us from the constraints of monolithic systems, unlocking a realm of possibilities. Developers can now think outside the box, exploring innovative solutions that were previously unattainable due to the rigid structure of monolithic systems. One of the most significant advantages of microservices lies in their ability to enhance scalability. In a world where user demands and data volumes are constantly growing, the need for scalable systems has never been more critical. By decomposing an application into smaller services, each service can be scaled independently based on its specific needs. This modular approach ensures that resources are allocated efficiently, optimizing performance and cost. This means that if a particular service experiences a surge in demand, it can be scaled up without affecting the performance of other services or requiring the entire application to be scaled. This flexibility is crucial for maintaining a seamless user experience. Another key benefit is improved fault tolerance. In today's digital landscape, system reliability is paramount, and microservices architecture provides a robust solution to this challenge. In a monolithic application, if one component fails, the entire system can be affected. This single point of failure can lead to significant downtime and loss of service, which can be detrimental to businesses. However, with microservices, the failure of one service is isolated, preventing a cascading effect on other parts of the application. This isolation ensures that the rest of the system remains operational, even if one component encounters issues. This resilience is crucial for building reliable and highly available systems. High availability is a key requirement for modern applications, and microservices architecture inherently supports this by design. Furthermore, microservices promote agility and speed in development. In an era where time to market is a competitive advantage, the ability to develop and deploy quickly is invaluable. Teams can work on individual services independently, without affecting other parts of the application. This independence fosters a more collaborative and efficient development environment. This allows for faster development cycles, as teams can release updates and new features more frequently and with greater confidence. The continuous delivery and integration pipelines are streamlined, ensuring that new functionalities reach users faster and more reliably. Additionally, microservices enable the use of diverse technology stacks. Teams can choose the best tools and languages for each service, promoting innovation and leveraging the strengths of different technologies. Seamless integration through APIs allows these diverse services to communicate effectively, creating a cohesive and functional application. This interoperability is a cornerstone of microservices architecture. Ultimately, microservices architecture future-proofs applications, making them more adaptable to change. As the software landscape evolves, microservices provide the flexibility needed to incorporate new technologies and methodologies, ensuring long-term viability and success. The adoption of microservices has witnessed a meteoric rise in recent years, with numerous companies embracing this architectural style to build and scale their applications. Microservices architecture breaks down a large application into smaller, independent services that can be developed, deployed, and scaled individually. This approach offers several advantages, including improved fault isolation, easier scalability, and the ability to use different technologies for different services. From industry giants to startups, microservices have proven their mettle across diverse domains. Companies are no longer constrained by the limitations of monolithic architectures, which often become unwieldy and difficult to manage as they grow. Instead, microservices allow for more agile development processes, enabling teams to iterate quickly and respond to market changes with greater flexibility. One such example is Netflix, the streaming giant that has revolutionized the way we consume entertainment. Netflix's journey with microservices began as a way to address the challenges of scaling its rapidly growing platform. By breaking down its platform into hundreds of independent services, Netflix was able to improve its development speed and system reliability. Netflix embraced microservices to handle its massive scale. breaking down its platform into hundreds of independent services. Each service is responsible for a specific piece of functionality, such as user authentication, content recommendation, or video streaming. This modular approach allows Netflix to deploy updates and new features more frequently without disrupting the entire system. This architectural shift enabled Netflix to achieve unparalleled scalability and availability, ensuring a seamless streaming experience for millions of users worldwide. The ability to scale individual services independently means that Netflix can handle peak loads more efficiently, providing a consistent and reliable user experience even during high-traffic events. Amazon, another tech behemoth, adopted microservices to power its vast e-commerce platform. The transition from a monolithic architecture to a microservices-based approach was driven by the need for greater flexibility and faster innovation cycles. By decomposing its monolithic architecture into smaller independent services, Amazon gained the flexibility and agility to innovate rapidly and respond to changing customer demands. Each microservice can be developed and deployed independently, allowing Amazon to experiment with new features and improvements without risking the stability of the entire platform. This architectural transformation played a pivotal role in Amazon's journey to becoming the world's largest online retailer. The ability to scale services independently and deploy updates frequently has enabled Amazon to maintain its competitive edge and continuously enhance the customer experience. These real-world examples highlight the transformative power of microservices in building highly scalable, resilient, and adaptable software systems. By breaking down complex applications into smaller, manageable pieces, companies can achieve greater operational efficiency and faster time to market for new features. By embracing this architectural style, companies across industries are unlocking new levels of efficiency, innovation, and customer satisfaction. The flexibility and scalability offered by microservices are driving a new era of software development, where businesses can rapidly adapt to changing market conditions and deliver exceptional value to their customers.